Physical Science 20 Introduction and Review, Acid and Covalent Nomenclature. This goes along with the IR13 and 14 assignments. Naming acids. Over the past few days, we've been looking at ionic compounds. Acids are also ionic compounds, but they behave very differently than the average ionic compound, and for that reason, have a unique naming scheme. The cation in an acid is always H+. This means the only difference between acids is the anion. Therefore, acids are named based on the anion found in the formula. Have you ever noticed that all the anions on the common negative ions list either end in "ide", "ate", or "ite"? On your formula sheet, there is a box that is titled Acid Naming. When you have an acid, you look at the anion, and if it ends in "ide", you add the prefix hydro, change "ide" to "ic", and then follow with the word acid. If the anion ends in "ate", you change "ate" to "ic", and follow with the word acid. And if the anion ends in "ite", you change "ite" to "us", and follow with the word acid. There are exceptions in suffix, which are sulfur and phosphor, which you will see later in this lesson. Example 1, H2SeO3. I've got two H pluses on the front, so SeO3 must have a -2 charge. I look up SeO3 2- on my negative ions list, and I find the name selenite. It ends in "ite", so I change "ite" to "us", and I follow with acid. So H2SeO3 is called selenous acid. Example 2, HOCN. I have H on the front, just one, so that means the OCN must have a -1 charge. So I go to my negative ions list and I look up OCN, minus, and I find cyanate. Since it ends in "ate", I change "ate" to "ic" and follow with the word acid. So HOCN is called cyanic acid. Example 3, HCl. I have one H, so that means the Cl has a -1 charge. I look it up on the common negative ions list. It's called chloride. Since I have an "ide" ending, I add the prefix hydro. I change "ide" to "ic", and I follow with acid. So HCl is called hydrochloric acid. Example 4, H2S. I have two hydrogens, so the S has a -2 charge. So I look up S2- on my negative list. I find sulfide, which ends in "ide. So I have to add the prefix hydro. I change "ide" to "ic", and I follow with acid. And that gives me hydrosulfic acid, but it's not boxed, and that's because it's not a final answer, because at the very bottom, remember, we have an exception in suffix when it comes to sulfur and phosphor acids. I need to add a right here. And that gives me then hydrosulfuric acid. Example 5, H3PO3. I have three hydrogens, so that means the PO3 has a -3 charge. When I look it up on my negative ions list, I find that it is called phosphite. Since I have an "ite" ending, I change "ite" to "us" and follow with acid. And that gives us phosphorus acid. Oh, that again doesn't sound right. Oh, the exception in suffix. So I have to have an "or" added right after the phosp. And that gives me then phosphorus acid. Phosphorus acid. That sounds better. Example 6, arsenous acid. I have us, O-U-S, and that means the original ending would have been "ite". So I'm looking up arsenite on my common negative ions list. It is a -3 charge, so to balance that off, I would need 3 H pluses to come before the anion. So the formula for arsenous acid is then H3AsO3. Example 7, hydroselenic acid. I have hydro and ic, and if I have hydro and ic, the original ending is "ide." So I'm looking up selenide on my negative ions list, and that is Se2-. Since I have a -2, I will need 2 hydrogens on the front. So the formula for hydroselenic acid is H2Se. Example 8, chromic acid. I have ic, but I don't have hydro. If I don't have hydro and ic, then the original ending cannot be "ide." Since it's just ic without hydro, that means the original ending was "ate." So chromate is what I look up on my negative ions list, and that is CrO4 with a 2- charge. Since I have a 2- charge, to balance it out, I will need 2 H's on the front of the formula. So chromic acid is H2CrO4. Example 9, CH3COOH. Right off the top, you may have noticed that this looks different than the other acids. And that's because we were told all acids have H plus at the front of the formula. But we clearly don't have any hydrogen at the top of this formula. Now, why is that? The H is actually on the back. But why is the H placed on the back of the anion instead of the front, like all the other acids? And that's because this is an exception. This is an organic acid that is very popular in chemistry, so we have to be familiar with it. Organic chemists like to write the formula the way that the elements are bonded to one another. If I were to draw this formula, it would look like this. The first C is connected to 3 H's. The second C is connected to an O and an OH. So they place the H at the back because that is where it is connected to the molecule. If I look this up on the negative ions list, I find CH3COO-. That is called acetate. Since it ends in ate, we change ate to ic, and we follow with acid. So CH3COOH is known as acetic acid. Again, very popular acid. You probably have this in your house because the generic name for this acid is vinegar. Naming covalent molecules. Covalent molecules. They're made of 2 nonmetals. They use a covalent prefix to identify the number of each element present. Note, there is an exception, mono. It is never used on the first element in the formula. And the end of the covalent molecule name is always changed to "ide." Start by finding the covalent numbering data table on your formula sheet. Then, by covalent, I would probably make a note that says "ide," since covalent molecules always end in "ide. And I would probably write 2 nonmetals, since covalent molecules are always comprised of 2 nonmetals. Example 1, C2O4. I have 2 C's. The covalent prefix for 2 is di. So 2 carbons is called dicarbon. Then I have 4 oxygen. The covalent prefix for 4 is tetra. So 4 oxygen is called tetraoxide. Remember, we changed the ending to "ide." So C2O4 is called dicarbon tetraoxide. Example 2, PCl4. I have 1 P. The covalent prefix for 1 is mono. So 1 phosphorus would be called monophosphorus. But there's an asterisk next to mono because mono is never used on the first element. So we just write phosphorus. Then I have 4 chlorines. Covalent prefix for 4 is tetra. So 4 chlorines is called tetrachloride. So PCl4 is called phosphorus tetrachloride. Example 3, P4O6. I have 4 P's and the covalent prefix for 4 is tetra. So 4 phosphorus is called tetraphosphorus. Then I have 6 oxygen. The covalent prefix for 6 is hexa. So 6 oxygen is hexaoxide. So P4O6 is tetraphosphorus hexaoxide. Example 4, carbon dioxide. I don't have a covalent prefix on the first element listed, but that's because I only have one of them. Remember, mono is never used on the first element listed. So since I have no covalent prefix in this covalent molecule, that means I have just one carbon. Then I see dioxide. Di means 2. So dioxide, that means 2 oxygen. So I write O2. So carbon dioxide is CO2. You're now good to start the assignment.